Alright, today's notes are starting to get into graphing inequalities. So we're going to look at two examples, and we already know how to graph, so we know with this one, this is an in-slope-intercept form, y equals mx plus c, y equals mx plus b, except that it's an inequality where it has its y is greater than or equal to the 2x plus 3. Well, we know that the slope, so our slope is still 2 over 1, and the y-intercept is 3. So we start at 3, so we're still going to do everything the same, where we start at 3, and the slope is 2 over 1, which means we go up 2 and right 1, up 2, right 1, up 2, right 1, or instead of going up 2, right 1, we can go down 2 and left 1, and we can continue this process down 2, left 1, down 2, left 1, and we can connect all of our points in our straight line. Now, so we graph normally, so we'll just make a few notes here. We graph normally. But now this is an inequality, which means we can get a range of answers. So range of answers. Now if we just, we look at this and we look at a couple different points, so just to see. So if I look at this point 0, 0, so if we look at 0, 0, now if we plug it in, so is 0 greater or equal to 2 times 0 plus 3? Well, is 0 greater than 3? Well, that's wrong. So we know that this point does not work. Well, let's try another point over here. This is 1, 2, 3, 4, 5, 1, 2, 3, 4. So this is the point 5, 4. So now I'm going to look at the point 5, 4. So we plug in 4 for y. Is 4 greater or equal to 2 times 5 plus 3? Well, 2 times 5 is 10. 10 plus 3 is 13. Well, is 4 greater or equal to 13? Well, that's not true. So that point doesn't work. So this point also doesn't satisfy this saying that it has to be greater than. Well, what if I try to look at a point over here? Well, now this is negative 2, 1, 2, 3, 4, 5. So we have the point negative 2, 5. So negative 2, 5, so we plug 5 in for y. So is 5 greater or equal to 2 times negative 2 plus 3? Remember, this is my x, this is my y. We're just plugging them in. So is 5 greater or equal to negative 4 plus 3? Well, 5 is greater than negative 1. That's true. So this is true. And if we try, let's just say we have one up here. Let's try one down here. So we'll select this point over here. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3. So negative 6, negative 3. So we have the point negative 6, negative 3. So we can plug them in again. So I have negative 3 is greater or equal to 2 times negative 6 plus 3. Well, is negative 3 greater than negative 12 plus 3 than negative 9? That's true also. So this is true. So if you start to notice, well, the points on this side of the graph are true, but the points on this side of the graph are false. So when we get an inequality, any point on this side right now is going to be true. So I can shade in this entire side of my graph because all of these points over here are true. So whichever point I select on this side of the graph is going to be true. It's going to satisfy my inequality, which y is greater than 2x plus 3. And I'm also going to show you a hint at the end of this. So we graph it normally, we get a range of answers, and we check to see which side of the equation is true. So we check points to see if they are true. So we just want to check to see if they're true or not. So the left side was true, the right side was false, so I shaded in my entire left side. And I can actually increase my size here, and we can shade in this whole area because that's all true. So that side of the equation, or the inequality, satisfies our example. When we look at the second example here, we have 2x plus 3y is less than or equal to 12. Well, since this is in standard form, so it's in standard form, so standard form, we could either write it in slope-intercept form or just find the x and the y-intercepts. Well, we know that the x-intercept, y equals 0, so we're just going to have 2x is less than or equal to 12, so x is less than or equal to 6. So we're going to plot this point 0, 6, or not, the point 6 comma 0. So our x-intercept, 1, 2, 3, 4, 5, is 6, 0. And we can also find the y-intercept. So for the y-intercept, the x value equals 0. So we just get 3y is less than or equal to 12. Y is less than or equal to 4. So now we can plot the point 0, 4. So 0, 1, 2, 3, 4. So now I have my 2 points. And then we can connect these with our straight line. I put arrows on it. And now, once again, I go all the way through my graph because this is an inequality. So half of the graph is going to be true and half of the graph is false. So it's standard form. We find the x and y intercepts. Then we graph it. And now we have our range of answers. So we have to check to see which side's true. So we're going to check to see which is true. To see points that are true. So we'll take a look at 0, 0. It's the easiest point to work with, so that's why I always use 0, 0. So now I have 0, 0. So that's the first point. So I have 2x plus 3y is less than or equal to 12. So 2 times 0 plus 3 times 0 less than or equal to 12. Well, 0 plus 0, that's true. So this is true. Now we can choose another point over here. So I'll choose right here. That's 1. Actually, we'll choose a different one so it's not on a 0. There we go. That's 1, 2, 3, 4. That's negative 5. 1, 2, 3. So the point negative 5, 3. So we do 2 times negative 5 plus 3 times 3. That's my x. That's my y. I plug them in. So negative 10 plus 9, well, that's negative 1, and negative 1 is less than 12, so that's true also. So it looks like these points are true. And then if we flip it around, I look at points on the other side. So I'll check this point, which is 1, 2, 3, 4, 5, 6, 7, 7, 3. So we check 7, 3. So we do 2 times 7, because that's my x. And this is the y, plus 3 times 3, and we plug 3 in for this. It should be less than or equal to 12. Well, this is 14 plus 9, which is 23, is less than or equal to 12. That's not true, so this point's false. We can check another one. We'll do 0, 9 to point 0, 9. So we have 2 times 0. Plus 3 times 9 should be less than or equal to 12. Well, that's 0. That's 27. 27 is not less than or equal to 12. This is also false. So once again, when we look at it, the points on this side of the graph are true. So that means everything on this side is going to be true, since that's where all of my true points were. And then the other side is false. Now a little hint here, if we look at this, this says it's less than, so x and y are less than. Well, it's going to be below the graph. Alright, so we're less than the graph. And whereas if we looked at the first one, y is greater than, that's above the graph. So if I look at my graph here, anything above it is going to be on that side. So we're above this graph. That's just a little hint. We'll practice with this a little bit more too. And that's just graphing inequalities. We do them the same way as equations, except we have to determine which side to shade. So one side it's true and the other side it's false.